Okay, I hope you had a chance to watch the short video on balancing kind of a non-standard reaction where all you had is ions. Now what we're going to look at is another facet of balancing redox reactions, and that is balancing them when they are in an acidic or basic solution. Okay, so we want to look at what happens when we put these or try to balance these in different types of solutions. So one of the things that you're going to see with these types of reactions is they're going to start out looking much different than what we're used to. What happens is they start out with different things that are usually ions. So what you have to remember is the key word that we are using here is these are already in some type of beaker that's in a solution, okay? So you just got to keep that in mind. Now, there are steps that are involved in balancing redox reactions in acidic basic solutions. And overall, there are 6 to 7 different steps depending on how I break down the last two. So what you're going to want to do is have a page kind of maybe for your steps, and then I would honestly have a new page just for this. It probably won't take a new page, but that's how I would start. So, page for this, page for this. Okay, I'm going to give you a moment. If you haven't already done so, write down this equation. Pause the video if you need more time. Okay, so like all redox reactions, the very first step that you have to take is to write the half reactions. Okay, so you need to pick out and write the half reactions. So that's step one. Pick out and write out what your half reactions are. Okay, now, when you have reactions like this, it is actually sometimes difficult to pick out what your half reactions are. So what you're going to look for are compounds that have the same elements in them. So, manganese and manganese with an oxygen both have manganese in them, so that's going to be one of your half reactions. Okay? So Mn2 plus is going to go to MnO4 minus. Okay? Now, I'm going to warn you right away, you want to leave some space between this half reaction and your next one. Okay? Just a little bit of space. But now, these are our only other two that are left, so they must be part of the next half reaction, and they both have Bi in them, which that's the connecting element. So that's why those are going to be your next half reactions. Okay, so you're looking kind of for a connecting element between them. So NaBiO3 goes to Bi3 plus. Okay, and I don't know if you've noticed this at all when I'm doing this, but one of the very hidden secrets that I really haven't said is you should always line up your yield signs. Your life will be much easier if you line up your yield signs. So try to do that. Rule 2, step 2. Step 2. Okay, didn't really mean to be in green, but oh well. You are going to balance all atoms except hydrogen and oxygen. In the half reactions. Okay, so you're going to balance all atoms, but we're going to, for right now, ignore hydrogen and oxygen. So going back to this, if I'm looking at this half reaction, okay, I want to balance Mn and Mn. And since there's one of each on both sides, Those are balanced, so I'm done with that. Okay? Now, the second reaction becomes a little bit trickier because there's one Bi over here and there's one here, and so that's good, but we have this Na and we have no Na over here. So this is where it's a little bit weird, okay? But I need to put an Na into the reaction, but one of the things that you're going to have to think about is Na is soluble, so this Na is going to go in as an ion. Okay? So, I now have that reaction balanced as much as I can because I have the atoms balanced. So now, we go to step 3. Step 3, now we look at the hydrogen and the oxygen. So we're going to balance the hydrogen and oxygen by adding either or both hydrogen ions or water. Okay, so you can add either one or you could add both. Okay, so going back to this. If I look at this first equation again, okay, looking at that first equation, I have 4 oxygens over there. I have no oxygens on this side, so I need to add oxygens. The only way you get oxygens is by adding H2O. Okay, so I have to add H2O to this side. But I have to get, so I have 4 of them. So I need 4 H2Os. Okay? Now my oxygens are balanced. Except now what you'll notice is there's no hydrogen over here, and I just added 8 hydrogens. Okay? And this is where the adding of H plus comes into play. So now I'm going to add hydrogen ions over to this side, but I have to add 8 of them. Okay? Now I'm done messing with that equation. Everything is balanced in terms of atoms. I have 8 hydrogens, I have 1 Mn, 1 Mn, and I have 4 oxygens and 4 oxygens. So everything over there is now balanced. And then we do the same thing to the bottom equation. And again, the difference between this side and this side are the oxygens. Okay, so we need to add H2O over to this side. Because the only way you get to add oxygen is by adding water. That's it. And then I need to add 3 of them. Okay, because I have 3 of them right there. And again, now we've messed up the number of hydrogens. So now I have 6 hydrogens over on this side. I need to get 6 hydrogens on the left. So I need to add hydrogen ions over here, and I need 6 of them. Okay? And now if you look at that equation, everything is balanced there. So we go to step 4. Okay, now that we have all of our atoms balanced, the next thing we need to do is balance charge. So we need to balance charge on both sides of the equation. By adding electrons. So This is where adding the electrons comes in. If you go back to the previous problem that we did, and I'm just going to hop back here for a second. Oops, right there. If we look at this problem from the last video, we added those electrons in right away. Right there and right there. Okay? Now, we've gone a long time without actually adding electrons. So I really actually at this point have no idea which is the oxidation and which is the reduction reaction until I get to this point. And this is where we need to add electrons. But this gets a little bit tricky because you have to balance the charge. And what that means is this whole side of the reaction has a charge. That charge is +2. This is 0 charge here, so 0 plus 2. The net charge over on the left side of this equation is +2. Okay, now over on the right side of this equation, I have a +8 from the hydrogens, and then I have a -1. So the net charge over here is +7. So on the right side of my equation, I have a net charge of +7. So somehow what I need to get to is the fact that those two charges are equal. The way we get those charges equal is by adding electrons. And on this positive side, adding electrons is going to reduce charge. So I'm going to put my electrons over on the right side. And if you think about this carefully, if I put 5 electrons over here, then +7 plus a -5, because that would be 5 electrons, gives me +2. So now my net charge over here is no longer +7, it's +2, and so charge and charge are balanced. Okay? Now, that same logic and thought process needs to happen with the second reaction. So again, look over here at this side. I have +6, so I have +6, and this is 0, so my net charge is +6. So over here I have a +6 net charge. And then now if I look over on this side, okay, I have a +3 and a +1. So my net charge here is +4. So this side has a +4 net charge. Okay? So now I need to add electrons to this equation. And again, electrons is going to reduce charge. So I'm going to want to put my electrons on this left side. Okay, so I'm going to want to put them here. And I'm going to want to put 2 electrons there. Okay? And the reason for that is -2 plus 6 gives me +4. And so this side is no longer +6, it's +4. Okay? So now my charge balances. And that's where we want it to be. Okay? But the other thing that to think about here is, again, when we talked about this earlier, remember our electrons should be on opposite sides, and they are. So that's actually a good check for us to make sure our electrons are on opposite sides. Great. Now we go to step 5. Okay? Step 5 is to equal out the number of electrons in both equations. I should say between equations. Okay? Because our ultimate goal here is we want to add the reactions together. Okay? So we want to add the reactions together. That is our ultimate goal. So we need to equal out the number of electrons between the two equations. Okay, so that means I have to look at both of these equations, and I have 2 electrons here, and I have 5 electrons there. Essentially, you are looking for a least common multiple. And in this case, it's 10. So if I take this top equation, okay, and I haven't used green yet. If I take this top equation and I multiply it by 2, that will give me 10 electrons. If I take this bottom equation and I multiply it by 5, sneak a 5 in there, okay, that will give me 10 electrons there. And then when I ultimately get ready, both equations will have electrons that cancel out. Now, I will tell you that this is where I rewrite the equations. Okay, so at this point, I'm not adding them together. I'm going to rewrite the equations, okay, to make my paper a little bit neater. Okay, so I am going to basically distribute this 2 to all of these terms, okay, and I'm going to rewrite the equation down below here. So 2 times 4 is 8 H2Os. Okay, so I just did this math. And then 2 times Mn, that's plus 2 Mn2 plus. That's going to yield 2 times this, which is 2 MnO4 minus, plus 2 times that, which is 16H plus 10 electrons. So I'm just kind of trying to clean up my work. That's all I'm doing. And then I'm going to do the same thing to the second equation. I'm going to take 2 times 6. I'm sorry. I'm going to take 5 times 2, okay, and that gives me 10 electrons, plus 5 times 6, which gives me 30 H pluses, plus 5 times that, which is 5 NaBiO3. That's going to yield 5 Bi3 plus 5 Na plus 15 H2O. And I still didn't make that a whole lot neater. Whoops. So, these are my 2 now rather large half reactions. And what I now want to do is I now want to add these 2 equations together. Okay? The first thing you should make sure of is your electrons cancel. Okay? If they don't cancel, you've done something wrong. Then you want to bring everything down, but you also want to combine like terms, okay? So I have 8 H2Os here, and I have 15 H2Os there, okay? So I'm going to draw a yield sign in here, and these 8 would take away 8 of these, so that's going to leave me with 7 H2Os, okay? Now that's taken care of as well, so I want to get rid of it, okay? Now, I have 2 Mn2 plus, so I'm going to write 2 Mn2 plus. So I've gotten that taken care of. And then I have 5 of these, so I'm going to write 5 NaBiO3. And I wrote too big. So I'm just going to remember that I only have 7 H2Os over here. Okay, and then I have 30 H pluses, and I have 16 H pluses. So 16 of those is going to take away 16 of these. That's going to leave me with 14 H pluses. Okay? Now, I've already taken care of that. That leaves me with 2 MnO4 minus plus 5 Bi3 plus 5 Na plus 7 H2O. And there you have it, ladies and gentlemen. You have a balanced chemical reaction that is in an acidic solution. This is why it's acidic, because of that right there. Okay? Now, we're done. And we can double check if we want to, but you have 2 MNs, you have 2 MNs, you have 5 NAs, you have 5 NAs, you have 5 BIs, you have 5 BIs, you have 15 oxygens, you have 8, 7, 15 oxygens, okay, and you have 14 hydrogens and 14 hydrogens. So, we balance out that way as far as our atoms go. Okay? And we're essentially done. We're done to the point of if we want a solution that's acidic, these directions give you a solution that's acidic every time. Okay? However, to make a solution basic, you add one step. Okay? To make a solution basic, all you need to do is add one step. And what you do is you add enough hydroxide ions, because these are the base, to eliminate all hydrogen ions. And if you think about this, what happens is if you have a hydrogen ion and I add a base to it, that's going to eliminate it by producing water. So that's how you make a solution basic, is you're going to add hydroxide to eliminate all the hydrogen. So we're going to go back to this. And right now, this is acidic. What we're going to do is we're going to make it basic. To make this basic, here's my hydroxide. I have 14 of them, so I'm going to add 14 hydroxides. Okay, now, little sidebar calculation. If I have 14 H pluses plus 14 H2O or H minuses, that's going to give me 14 H2Os. Okay, so all of this is going to turn into 14 H2Os. However, this is just like math class. And whatever you do to one side of the equation, I must do to the other side of the equation. So if I added 14 OHs to the left, I must add 14 OH minuses to the right. Okay? Now, I have a mess again, so I'm going to rewrite. Okay? And in my rewrite, a lot of the stuff hasn't changed. So, you still have 2 Mn2 plus. You still have your 5 NaBiO3. Okay? Now, you do have 14 waters, and then we had 7 waters here. Okay? And so those 7 waters will take out 7 of those waters, so I'm just combining like terms. That's going to yield 2 MnO4 minus plus 5 Bi3 plus 5 Na plus 14 OH minuses. And this now makes this a basic solution. So that is balancing oxidation reduction reactions in acidic or basic solutions.